Chiedo pertanto al professore Kite Jones, che è della Università Ruskin, Anglia-Ruskin, che è il coordinatore del progetto Liquefact, di fare la sua relazione. Grazie.
Thank you. Welcome to Liquefact. My name is Professor Keith Jones. I'm Head of Department of Engineering and the Built Environment at Anglia-Ruskin University. My academic background is as an engineer originally. I am now a Professor of Facilities Management, focusing on disaster management and disaster recovery to natural and man-made disasters. And I am the project lead for the Liquefact project. The Liquefact project is an EU-funded project under the Horizon 2020 programme. Its focus is to investigate the factors that affect community resilience to earthquake-induced liquefaction disaster events. It's funded under a call under the Critical Infrastructure Protection, and its aim is to produce demonstration activity on the best way to adapt buildings and critical infrastructure in vulnerable locations across Europe to improve community resilience. It's a 42-month project and it's funded to 4.9 million euros. The specific aims of the project are to understand more comprehensively and holistically the phenomena that is liquefaction, to look at where liquefaction events may occur across Europe and to assess their impact, to look at the effectiveness of existing and new mitigation techniques to reduce vulnerability of structural and non-structural systems and components, and to develop a business model to support the inclusion of such mitigation events into new build and existing buildings. Specifically, the project seems to establish the baseline risks, so to develop and test a methodology and associated tools to assess the risk that a community, either an area or a region, may face from a liquefaction event. So that involves risk mapping, risk assessment, and risk reduction. To establish the specific impact that an event may have on a community, so to develop and test a methodology and associated tools to assess vulnerability, resilience, and resistance of critical buildings and infrastructure to liquefaction events, and to assess the impact of such events on the reduction in the functionality of these assets as they seek to support and serve the community. To examine mitigation options, to identify and evaluate new options and existing options that can either be integrated into the design of new infrastructure or can be retrofitted to existing infrastructure. So we will explore new buildings and new design. We will explore existing buildings within 4 regions across Europe, and we will focus specifically on what is needed to enable a community to recover following a liquefaction event. We will also seek to identify what is actually meant by adaptive capacity. So again, we will look to develop tools that identify and realise the adaptive capacity of a community, be that economic, political, social, or business, or any other factors that throughout the duration of the project we recognise and we integrate into the project. So in simple terms, what are the factors that affect the resilience of a community to a liquefaction event? How do they affect vulnerability? How do they affect resistance? And how do they affect adaptive capacity? So how does an event actually affect the community? What is it about the event that is critical to the function of that community and the speed with which that community recovers? How do existing solutions and plans address these impacts? Are they appropriate? Are they appropriate at the right scale? And do they address the right issues? And do the systems exist to respond to these impacts and find solutions to the problems? I'm sorry, the next 4 slides are in English only. So what we have done at the moment is we've looked at the theory from around the world of what happens when a disaster event occurs. So this model is the disaster resilience of place. And it argues that an event, or the impact of an event, is affected by the situation that exists within the community before the event and the coping responses that exist after the event. And the impact of the hazard is then mitigated to a greater or lesser extent by these systems. If the systems work well, recovery is quick. If the systems work poorly, recovery is slow. Now that suggests a linear approach to disaster management. And most people in the field realise that that is a simplification. It just isn't what happens in reality. This is a model developed by Patton following initially following volcanic eruptions in New Zealand and then modified following the earthquakes in 2011-12. And this suggests a much more complicated approach to the factors that affect the resilience of a community. It suggests that there are personal factors at the individual level which need to be understood, that there are factors at the community level which need to be understood, and then there's the factors at the institutional level, all of which work together to either inhibit or help a society or community recover. And some factors cross boundaries and some don't. Another view, developed this time by Boone, also considers community resilience as a complex system. Boone looked at it in a slightly different way. Rather than looking at individual actors within a system, he looked at different types of system. So the microsystem, the mesosystem, the exosystem, and the macrosystem. And although some of the factors are similar, Boone looked at what factors crossed system boundaries and what factors didn't, what factors remained within a system and how they interrelated. Another model based upon recovery was developed by Britt, and in this model they looked at what was needed in a society in order to aid recovery. So there was a cultural environment which was seen as the foundation, the bedrock, from which a system of support needed, and that is the trunk of the tree. So fairness and equity, organisations, community. So some of the similar names, some of the similar concepts are emerging. And then they help. They help the tree recover, they help society move forward. So if we go back to a model that I developed, based in London in 2012, looking at resistance to flooding, and in particular to climate change, we asked the question, if it's a complex system of systems, how quickly can businesses recover and get back to work? Where do householders actually get the assistance they require from? And more importantly, do they know where to get the assistance from? And what can be done to prepare for an event? But more importantly, it's the arrows that join together those groups that actually ultimately affect the community resilience and the speed at which the community can recover. So community resilience is a complex phenomenon that requires an understanding of the factors that affect individual stakeholders' vulnerability, resilience and adaptive capacity, but also the interrelationships between stakeholders as these affect the community resilience. There have been many studies of the former, there have been less of the latter. The Liquefact project will examine this as a holistic approach. It will develop a toolbox that will allow stakeholders responsible for managing disaster recovery to evaluate the potential of alternative mitigation techniques to improve resilience. So that's what we mean by a toolbox. And again, apologies, this slide is only in English. So how do we measure vulnerability and resilience in a way which is meaningful and in a way that those making decisions at the household, the business, or the political level can actually use? What are the technical mitigation measures that can be fitted to new buildings or retrofitted to existing buildings? How do we deal with the community? What can we do at a community level to aid mitigation? And do those systems exist? What is adaptive capacity in a European context? How do we recognise it? How do we enhance it? How do we develop it? And why should we do anything at all for a phenomena that may never happen? People who own buildings have other calls on their money, other issues they have to address. So how do you raise the priority of mitigation to a liquefaction event alongside other drivers which are probably more pressing on a day-to-day basis? So what tools and standards can we develop? That is Liquefact. It is a 42-month project with many partners drawn from across Europe. My colleagues today will actually explain to you in more detail the individual parts. For my part, I've finished. Welcome to Liquefact. I hope you find the day interesting. There are our partners. And before I finish, may I thank Anglia-Bologna region for hosting us today. Thank you. And I hope you enjoy the rest of the presentations. Thank you.